Today we'll discuss numerical solution to differential equations. Now in engineering practice, we have different laws and corresponding mathematical expression. For example, Newton's second law of motion, that is force is equal to mass into acceleration. Now this equation can be written as, in place of acceleration we can put dv by dt. Okay, so equation becomes dv by dt is equal to f upon m. Similarly, Fourier's heat law, q is equal to minus k dt by dx, like that. Now we need the solution of these equations. So how to find out solution of these equations, we'll see. So we have one physical law, that is force is equal to mass into acceleration. It can be rewritten as dv by dt is equal to g minus c upon m into v. So this equation is for the following parachutist problem, which we have already discussed many a times. Okay, so now this equation can be solved using two methods. First method is analytical method. So if we are able to find out integration of this equation, that is v is equal to integration dv by dt. Okay, so if we are able to find out integration of this equation, we will get the equation for v. But in engineering practice there are number of problems where we are not able to find out the solution of the equations. So at that time what is to be done? We will use one of the numerical method. Now in numerical method we will get values of the variable at discrete points. For example, here vi plus 1, okay, we will get with the help of initial value vi plus 1, vi plus 2, etc, etc. Now at, you can see, left hand side analytical solution, we have got one equation and we will get continuous curve, that is continuous variation of that variable. If an ordinary differential equation is given, dy by dx is equal to minus 2x cube plus 12x square minus 20x plus 8.5, and we need to find out the variation, that is y. So y will be equal to dy by dx if we are able to find out the actual solution, that is true solution. So if we integrate it with initial conditions x0, y equal to 1, so we will get this equation y is equal to minus 0.5 x raised to 4 plus 4x cube minus 10x square plus 8.5x. So here in this figure you see this black curve. Okay, it shows the actual variation of y. Next we will implement Euler's method, where y at 0.5 is equal to y of 0 plus slope at 0, 1 into 0.5, that is h. So this comes, now when we put all these things in the equation, we'll get y at 0.5 is equal to 5.25, whereas the true solution, if you put this value of 0.5 into the equation, we will get 3.21. So you can see in the graph there is a certain difference. On this black curve you will get the true solution at 0.5, that is 3.21, and the solution from Euler's method, it is 5.25, that is the blue curve, you can say, and we have number of discrete points. Next we can compare the values of actual solution, that is y true, and the values from Euler's method at different points. So you see at 0.5 Euler's method gave 5.25 value, whereas true value is 3.218, and at x is equal to 1, Euler's method gave 5.87, whereas true value is 3. So there is a difference between these two values because Euler's method or the numerical method is an approximate method. And now in our next lecture we will discuss what is Euler's method in detail with example. Okay, thank you.